Number 10. The history of Mercury. Before we really deep dive into the facts about the planet, let's talk about the beginnings of the planet in terms of its discovery from our perspective. Obviously, Mercury was made billions of years ago, but when exactly did we discover it? The earliest known recorded observation of Mercury are from the Mull-Apen tablets. These observations were most likely made by an Assyrian astronomer around the 14th century BC. The cuneiform name used to designate Mercury on the Mull-Apen tablets is translated as the jumping planet. Babylonian records of Mercury date back to the 1st millennium BC. The Babylonians called the planet Nabu, after the messenger to the gods in their mythology, which is ironic because Mercury is the name of the messenger god to the Roman pantheon. Many other civilizations found out about Mercury in their own ways, including the ancient Greeks, Roman, Chinese, and even the Maya. The first telescopic observations of Mercury were made by Galileo in the early 17th century. Although he observed phases when he looked at Venus, his telescope was not powerful enough to see the phases of Mercury. In 1631, Pierre Gassendi made the first telescopic observations of the transit of a planet across the Sun when he saw a transit of Mercury predicted by Johannes Kepler. In 1639, Giovanni Zuppi used a telescope to discover that the planet had orbital phases similar to Venus and the Moon. The observation demonstrated conclusively that Mercury orbited around the Sun. In the 1880s, Giovanni Schiaparelli mapped the planet more accurately and even perfectly detailed its orbital time around the Sun. As more time went on, more time was devoted to studying Mercury, including in the 1970s when NASA launched the first craft to Mercury via the Mariner 10. The Messenger and the Bepi Colombo would later follow in its footsteps. For the record, the Bepi Colombo is set to reach Mercury in 2025. Though there is still a lot we don't know about Mercury, we do know a lot based on probes and pictures and studies that have tided us over for the last few decades, which is why Mercury, like other planets, is well known enough to teach about. Number 9. Orbits and rotations. Mercury is a very interesting planet in a whole host of ways, not the least of which is because of the fact that it is indeed the closest planet to the Sun. Because of this, it has certain perks, as well as disadvantages. First and foremost, it's the closest planet to the Sun and the second hottest planet in the solar system after Venus. It's only 29 million miles from the Sun at its closest. Now yes, I'm sure this seems like a long distance, but when you're talking about the Sun, a sun that is 860,000 miles in diameter, that's not as far as you think. Because of this, it only takes about 88 days for Mercury to have a year-long rotation around the Sun, which is elliptical in nature for the record. And as for how long a day is, well, that's where the twist comes in. Because you see, a day is the amount of time it takes for the planet to rotate around its axis, right? Well, for Mercury, it has a very slow rotation. In fact, if you do the math, that would mean that the day count for about a year on Mercury is just over 1.5 days. That's some really weird planet calendar, but that's just how Mercury is. Number 8. How hot does it get there? The surface temperature of Mercury ranges from 100 to 700 Kelvin, minus 173 to 427 degrees Celsius, minus 280 to 800 degrees Fahrenheit, at most extreme places. It never rises above 180 Kelvin at the poles, due to the absence of an atmosphere and a steep temperature gradient between the equator and the poles. The sub-solar point reaches about 700 Kelvin during perihelion, 0 degrees west or 180 degrees west, but only 550 Kelvin at aphelion. On the dark side of the planet, temperatures average 110 Kelvin. The intensity of sunlight on Mercury's surface ranges between 4.59 and 10.61 times the solar constant. Although the daylight temperature at the surface of Mercury is generally extremely high, observations strongly suggest that ice, frozen water, exists on Mercury. The floors of deep craters at the poles are never exposed to direct sunlight, and temperatures there remain below 102 Kelvin, far lower than the global average. Water ice strongly reflects radar, and observations by the 70-meter Goldstone Solar System radar and the VLA in the early 1990s revealed that there are patches of high radar reflection near the poles. Although ice was not the only possible cause of these reflective regions, astronomers think it was the most likely. Regardless of that though, these extreme temperatures are why Mercury is such a different planet compared to the rest of the solar system. Number 7. The atmosphere. When thinking about a planet, one of the most considered things is the atmosphere, because through that we get a look at how the surface is affected and how life might be able to survive there. Mercury is too small and hot for its gravity to retain any significant atmosphere over long periods of time. It does have a tenuous surface-bound exosphere containing hydrogen, helium, oxygen, sodium, calcium, potassium, and others at a surface pressure of less than approximately 0.5 nPa, 0.005 picobars. This exosphere is not stable. Atoms are continuously lost and replenished from a variety of sources. Hydrogen atoms and helium atoms probably come from the solar wind, diffusing into Mercury's magnetosphere before later escaping back into space. Radioactive decay of elements within Mercury's crust is another source of helium, as well as sodium and potassium. Now, all of that being said, Mercury has a significant and apparently global magnetic field. According to measurements taken by Mariner 10, it is about 1.1% the strength of Earth's. The magnetic field strength at Mercury's equator is about 300 Nt. Like that of Earth, Mercury's magnetic field is dipolar. Unlike Earth's, Mercury's poles are nearly aligned with the planet's spin axis. Measurements from both the Mariner 10 and the Messenger space probes have indicated that the strength and shape of the magnetic field are stable. It is likely that this magnetic field is generated by a dynamo effect, in a manner similar to the magnetic field of Earth. This dynamo effect would result from the circulation of the planet's iron-rich liquid core. Particularly strong tidal effects caused by the planet's high orbital eccentricity would serve to keep the core in the liquid state necessary for this dynamo effect. Number 6. Life on Mercury? Given some of the things we just talked about, I'm sure it's a little weird for some of you that many think that there could have been life on Mercury at one point in time, and yet it's true. There may be scientific support based on studies reported in March of 2020 for considering that parts of the planet Mercury may have been habitable and perhaps that life forms, albeit likely primitive microorganisms, may have existed on the planet. The keywords you have to remember here are may have existed and parts of the planet Mercury, because while it is a planet that has a very rough surface and very fluctuating temperatures, it's also a planet that is surprising in how it has both ice and water vapor, and water is a key basis for life anywhere, including on Earth and on Mercury. Granted, no actual proof has been found that life was on Mercury, or when it was there and when it apparently died out. But if there is even a small chance that it was there at one point, you can bet that people are going to look into it, because if something can live on Mercury, even in the smallest of forms, it gives many hope for life on many other planets in the universe. Number 5. Mercury is big in pop culture. The smallest planet in our solar system has a big presence in our collective imagination, which is a bit interesting considering how much more popular the other planets are compared to Mercury. Scores of science fiction writers have been inspired by Mercury, including Isaac Asimov, C.S. Lewis, Ray Bradbury, Arthur C. Clarke, and H.P. Lovecraft. Television and film writers too have found the planet an ideal location for storytelling. In the animated television show Invader Zim, Mercury is turned into a prototype giant spaceship by the extinct Martians. And in the 2007 film Sunshine, the Icarus II spacecraft goes into orbit around Mercury to rendezvous with the Icarus I. In the comic strip Calvin and Hobbes, Calvin and his classmate Susie give a presentation about Mercury, in which Calvin's contribution is full of questionable information. The planet Mercury was named after a Roman god with winged feet, says Calvin. Mercury was the god of flowers and bouquets, which is why today he is a registered trademark of FTD florists. Why they named a planet after this guy, I can't imagine. Despite Calvin's analysis, Mercury has been used even more than that, which goes to show that when it comes to storytelling, just about any planet is a viable option for something. Number 4. Natural disasters. Here's something you may not know. Because of its proximity to the Sun and the lack of a true atmosphere, Mercury has no seasons, not a single one, which you would think would mean that Mercury doesn't have any natural disasters happen to it like they are on Earth. But that is only half true. Yes, in regards to things like rainstorms or tornadoes or hurricanes, Mercury will never have to worry about those at all. However, in regards to earthquakes, it is believed to have them. but not in the way you're thinking. Earth has earthquakes because of tectonic activity, but in regards to Mercury, it likely has earthquakes because the Sun is quite literally shrinking the planet via its gravitational pull. What's more, because of the protective atmosphere and a weaker magnetosphere than what Earth has, Mercury is subjected to many different impacts from asteroids and meteors. Number 3. No moons or rings. It may seem rather obvious to indicate that Mercury has no moon or no rings. But what makes that such an important fact is that it's one of the few planets in our solar system that doesn't have a moon. Think about it. How many planets in our solar system don't have a moon? The answer is 2, Mercury and Venus. The reason they don't have a moon is honestly very simple. Because of how close they are to the Sun, the gravitational pull of the Sun is much greater than the planets. Thus, if any entity tried to make itself the moon of one of these planets, the Sun's exertion would pull it away. This is the same reason they don't have rings, as any debris would be plucked away by the Sun. Number 2. Gravity. Another major thing that is thought about when it comes to planets we might colonize is gravity. How much gravity a planet exerts will drastically affect its inhabitants and the planet itself. In the case of Mercury, the planet is one that has gravity 62% less than that of Earth, which means that if you weighed 100 pounds on Earth and somehow got to Mercury, your body weight, not including the spacesuit of course, would equal just 38 pounds. That means that you would be able to go and jump very high on the surface of the planet, but it also means that because of the reduced gravity, you would have to work very hard in order to ensure that your bones don't become brittle and weak due to the lesser forces exerted on it. Number 1. Could we live on Mercury? One of humanity's greatest things is the ability to think about possibilities. And when it comes to space, the possibility that everyone talks about is being able to live on other planets. Most agree that Mars is going to be the first planet we colonize. But what about Mercury? Could we live there? Technically speaking, we could, if we had the right amount of technology. It would be possible to shield ourselves from the Sun and the massively fluctuating temperatures, which would be one of the biggest initial hurdles for colonizing there. However, the disadvantages of trying to live there far outweigh any pluses. True, we would have almost unlimited solar power, so that would be a plus. However, with no long-term atmosphere, as noted earlier, a planet that is only 2/5 the size of Earth, the tidally locked rotation, the supreme lack of gravity, soil that very likely won't support growth of crops and more, we'd have an even harder time colonizing Mercury than we would colonizing Mars. And colonizing Mars is going to be quite an endeavor. Could it be possible one day to colonize Mercury? Absolutely. With the right technology, anything is possible. But will we colonize Mercury? That's another story. Number 8. The history of Venus. Before we get into the facts and figures and the numbers behind the planet that is Venus, we probably should talk about how we discovered it. After all, astronomy has been going on for a very long time, and people have found planets like Venus before you would expect them to. In the old Babylonian period, the planet Venus was known as Ninciana, and later as Dilbat. The name Ninciana translates to Divine Lady, illumination of heaven, which refers to Venus as the brightest visible star. The ancient Greeks initially believed Venus to be two separate stars, Phosphorus, the morning star, and Hesperus, the evening star. Pliny the Elder credited the realization that they were a single object to Pythagoras in the 6th century BCE, while Diogenes Laertius argued that Parmenides was probably responsible for this rediscovery. Though they recognized Venus as a single object, the ancient Romans continued to designate the morning aspect of Venus as Lucifer, literally light bringer, and the evening aspect as Vesper, both of which are literal translations of their traditional Greek names. When the Italian physicist Galileo Galilei first observed the planet in the early 17th century, he found it showed phases like the moon, varying from crescent to gibbous to full and vice versa. When Venus is furthest from the sun in the sky, it shows a half-lit phase, and when it is closest to the sun in the sky, it shows as a crescent or full phase. This could be possible only if Venus orbited the sun, and this was among the first observations to clearly contradict the Ptolemaic geocentric model that the solar system was concentric and centered on Earth, which was one of many theories about how our world and our universe were at the center of it all, when in fact that couldn't be farther from the truth. The atmosphere of Venus was discovered in 1761 by Russian polymath Mikhail Lomonosov. Venus's atmosphere was observed in 1790 by German astronomer Johann Schroeder. Schroeder found when the planet was a thin crescent, the cusps extended through more than 180 degrees. He correctly surmised this was due to scattering of sunlight in a dense atmosphere. Later, American astronomer Chester Smith Lyman observed a complete ring around the dark side of the planet when it was at inferior conjunction, providing further evidence for an atmosphere. Believe it or not, it wasn't until the 1900s when more details and research was done on Venus, mainly because its shape, distance, and phases didn't give a lot of clues as to its various inner workings. Radar observations in the 1970s revealed details of the Venusian surface for the first time, thus giving scientists much more to work with. The first robotic space probe mission to Venus, and the first to any planet, began with the Soviet Venera program in 1961. The United States' exploration of Venus had its first success with the Mariner 2 mission on December 14, 1962, becoming the world's first successful interplanetary mission, passing 34,833 kilometers, 21,644 miles, above the surface of Venus and gathering data on the planet's atmosphere. Since then, numerous probes and satellites have been taken to Venus to study it in some capacity. There have even been talks of putting a rover on the planet in the same style that NASA has done with Mars, but that hasn't happened as of yet. Number 7. Orbits and rotations. Venus is known as our sister planet because in many ways it's like Earth. It's only a little bit smaller, has an atmosphere that is full of gases, and we do know that it has a distinctive surface like certain other planets in our solar system, but we'll get to that more later. Although it should be noted that despite the similarities to Earth, there are just as many differences that we'll be covering a lot in this list for various reasons. If you want to get really trippy on how different Earth and Venus are, you need to talk about how Venus handles its days and years. Because not unlike its own neighbor, Mercury, Venus has a very slow rotation, but to the extent that it's actually longer than a year. Yeah, that's right, a day is longer than a year on Venus. Its orbital period, or how long it takes to make a full rotation around the Sun, is about 225 Earth days, whereas a singular day on Venus is 243 days. That's weird. More than that though, it feels rather counterintuitive, because especially with how we live here on Earth, when it comes to years, they're the longest basic measurement of time. Many years make a decade, and so on. But when you think about how we count our lives, it's in years. So for a single day on Venus to be more than a year on Venus, that's really weird. And yet that's exactly what happens on the planet. So if we're going to live there, more on that in a bit as well, we're going to have to get used to some very funky things. Number 6. Seasons. When it comes to the seasons on Venus, it's definitely not like Earth is in any measure. In fact, it's kind of worse. As you likely know, the temperature on Venus is extremely hot. The average temperature is about 460 degrees Celsius due to the greenhouse effect that essentially turned the planet into an oven. That's a big reason why we don't dare try and colonize Venus, because anything we make would have to be able to withstand that heat, and that's not easy. A heat, by the way, that makes it the hottest planet in our solar system, even beating Mercury, which is closer to the Sun than Venus is. Plus, the tilt of the axis on the planet is so minimal that the temperature honestly doesn't change much on the surface of the planet. So seasons, as we know them, would be mostly hot to very hot, with little regard for things like cold or cool. When you add that up, it means that Venus is a place that nobody wants to live on, unless you're talking about in the atmosphere, where it's technically possible for us to live, but we'll get to that in a bit. Number 5. Greenhouse effect. Let's be honest here, when you think about Venus, you no doubt think about how it's a greenhouse planet, meaning that it has gases within its atmosphere that trap heat at such a rate that it makes it boiling hot. And that's very, very true. Studies have suggested that billions of years ago, Venus's atmosphere was much more like the one surrounding Earth, further proving it to be our sister planet, and that there may have been substantial quantities of liquid water on the surface. But after a period of 600 million to several billion years, a runaway greenhouse effect was caused by the evaporation of that original water, which created a critical level of greenhouse gases in its atmosphere. As a result, the planet is so hot that it can melt lead. And to many, Venus is the perfect example of what will happen to Earth if we're not careful with how we handle our own greenhouse gases. Number 4. Volcanic activity. When you think about Earth, it has many things that can shape the land, and one of them is volcanoes. They literally create islands when they erupt out of the ocean, and they can cause widespread destruction when they're erupting above the waters, like with Pompeii or Montana. Yet, did you know that Venus has a lot of volcanoes as well? What's more, it helped make the planet what it is today. Much of the Venusian surface appears to have been shaped by volcanic activity in some way, shape, or form. Venus has several times as many volcanoes as Earth, and it has 167 large volcanoes that are over 100 kilometers, 62 miles across. The only volcanic complex of this size on Earth is the Big Island of Hawaii, 154. This is not because Venus is more volcanically active than Earth, but because its crust is older. Earth's oceanic crust is continually recycled by subduction at the boundaries of tectonic plates, and has an average age of about 100 million years, whereas the Venusian surface is estimated to be 300 to 600 million years old. The volcanic activity is also believed to be a major reason that the atmosphere is what it is today, but more on that in a sec. Number 3. Pop culture. Named after the goddess of love and beauty, Venus has become nearly synonymous with women in popular culture. As referenced by the famous relationship guide Men Are From Mars, Women Are From Venus. Venus has also been used as the name for various beauty products and lyrics in songs like I'm Your Venus. As a solar system locale, Venus was a popular destination for early 20th century science fiction writers, before we knew about what lay beneath Venus's mysterious cloud cover. Writers could speculate about a more hospitable planet and its possible inhabitants. More recently, Venus has been a backdrop for video games such as Transhuman Space, Battlezone, and Destiny. And in the Disney animated film The Princess and the Frog, Ray the Firefly falls in love with Venus, the evening star, as he has mistaken it for another firefly. Various other sci-fi television shows and movies have made their own stakes on what Venus would be like as well, making it all the more curious to some that were not trying to colonize it and instead going to Mars, but there are many reasons for that. Number 2. Atmosphere. When it comes to planets, one of the first things that people talk about in regards to habitability is that of the atmosphere, which is where we get a major problem. Conditions on the Venusian surface differ radically from those on Earth because its dense atmosphere is 96.5 carbon dioxide, with most of the remaining 3.5 being nitrogen. If you're keeping track, that means that the planet has virtually no oxygen. To be clear, Earth's atmosphere doesn't have all oxygen either, but it's balanced with the elements of nitrogen, carbon dioxide, and others in order to let us breathe. But on Venus, that would be impossible for a whole host of reasons, not just that there's no oxygen in it for the most part. For example, remember those volcanoes we talked about earlier? They had a significant impact on the atmosphere because they added loads of sulfur into it. The atmosphere is acidic because of it. Sulfuric acid, if you're wanting the more scientific term. There is literally a cloud layer on Venus that is comprised of it. If that's still not enough for you, the mass of its atmosphere is 93 times that of Earth's, whereas the pressure at its surface is about 92 times that of Earth's. A pressure equivalent to that at a depth of nearly 1 kilometer, or 0.62 miles, under Earth's oceans, which means that any attempt to put a human on the surface of Venus would need a suit to be specially pressurized to combat the atmosphere. Number 1. Cloud City on Venus. I want you to picture Star Wars for a second, specifically Cloud City from The Empire Strikes Back. Remember how it was a city that was quite literally floating above the clouds? Well, there are some scientists who believe that we could do something like this on Venus and have a better life there than on the ground. How does that work? Simple. On the ground, the gases of Venus are so dense and troubling that having a colony there would be problematic. However, the higher you go into the atmosphere, the thinner the gases get. And scientists have theorized that at about 30 miles above the ground, there is a sweet spot that humans could use to survive long term, as well as a spot that is modest in temperature and pressure exerted. How do we get to be in a spot 30 miles above the surface? With a floating city or colony of sorts. I can hear the question in your mind, but wouldn't it be hard to keep the floating city afloat? Usually, yes, it would be, which is why, barring anti-gravity technology, we'll never have such a city on Earth. However, on Venus, the many gases in the atmosphere could be used by the blimps or however the colony is built to keep it afloat. It's actually been proposed before by scientists and is technically feasible with the technology we have right now. Plus, unlike a domed colony that we would have to have on Mars or the Moon, if something were to happen to the blimp, say a small tear in the hull, it wouldn't crash the whole thing or cause a series of catastrophic events that would kill everyone, as Venus's atmosphere is thick like Earth's, so we would have time to fix it before things got bad. And as noted, the pressure and temperature of the spot in the atmosphere the colony would be means that keeping it cool or warmed wouldn't take much energy or effort. Now, can we definitely say that we're going to be colonizing Venus soon? Of course not. That would be foolish. But whereas we were once very deterred from the notion, there is a chance and possibility now that this could happen, which is not unlike where we were with Mars at the beginning of the new millennium. And if we can get something working on Mars with its issues, something on Venus doesn't seem so far-fetched. Number 9. How we found Mars. If astronomy has taught us anything, it's that the earliest civilizations that were on Earth were incredibly advanced in not just looking at the stars above, but understanding what the various things in the night sky were and naming them to help them understand more. And that includes finding Mars and understanding what it was. Some of the early records of Mars's observation date back to the era of the ancient Egyptian astronomers in the 2nd millennium BCE. Chinese records about the motions of Mars appeared before the founding of the Zhou dynasty, 1045 BCE. Detailed observations of the position of Mars were made by Babylonian astronomers who developed arithmetic techniques to predict the future position of the planet. The ancient Greek philosophers and Hellenistic astronomers developed a geocentric model to explain the planet's motions. Measurements of Mars's angular diameter can be found in ancient Greek and Indian texts. In the 16th century, Nicholas Copernicus proposed a heliocentric model for the solar system in which the planets follow circular orbits around the Sun. This was revised by Johannes Kepler, yielding an elliptic orbit for Mars that more accurately fitted the observational data. So just in the finding of Mars, you had a handful of civilization not just finding Mars, but slowly learning more about it long before the modern age of astronomy ever came about, which just makes it all the more impressive that they were able to learn so much. In terms of the modern age, the first telescopic observation of Mars was by Galileo Galilei in 1610. Within a century, astronomers discovered distinct albedo features on the planet, including the dark patch Syrtis Major Planum and polar ice caps. They were able to determine the planet's rotation period and axial tilt. These observations were primarily made during the time intervals when the planet was located in the opposition to the Sun, at which points Mars made its closest approaches to the Earth. Better telescopes developed early in the 19th century allowed permanent Martian albedo features to be mapped in detail. The first crude map of Mars was published in 1840, followed by more refined maps from 1877 onward. When astronomers mistakenly thought they had detected the spectroscopic signature of water in the Martian atmosphere, the idea of life on Mars became popularized among the public. Percival Lowell believed he could see a network of artificial canals on Mars. These linear features later proved to be an optical illusion, and the atmosphere was found to be too thin to support an Earth-like environment, but we'll get to that later. Still, just in the discovery of Mars and its most basic elements camp across thousands of years of discovery and investigation, and to this day we're still learning a lot about Mars. Number 8. Orbits and rotations. If you somehow haven't heard, the world is trying to get humanity onto Mars so that colonies can start to be formed. But to truly help people adapt to that notion, certain variables need to be understood, like how the orbits of Mars works, and the seasons that the planet may or may not have. First and foremost, a year on Mars is almost double that on Earth. Earth is 365 days and Mars is 687 days. This is due to the fact that Mars is much farther away from the Sun than Earth is, and thus has farther to go. Now on the flip side though, the rotation of Mars is just barely slower than Earth's. So instead of a 24-hour day, we actually have a 25-hour day more or less. The actual number is 24.62. That's not too bad of a twist, right? As for the seasons, that's a bit trickier, because on one hand it does have spring, summer, fall, and winter in the overarching sense, but they all pretty much last over 150 days, roughly, versus the 90-day average of Earth. Spring, if you can call it that, even goes as long as 7 months. Winter is the shortest with about 120 days. Plus, since Mars's orbit is elliptical and not circular, it has 2 additional seasons called aphelion and perihelion, meaning that it's got a new season when it's closest to the Sun, and 1 season when it's farthest away from the Sun. If humanity is going to last on Mars, we're going to need to adapt to the seasonal changes, especially in regards to how the temperatures on the planet can swing wildly from day to night, as well as season to season on the surface. It's not an impossible thing to overcome, but it's something we'd have to be ready for. Number 7. Water on Mars. Without a doubt, one of the most important discoveries on Mars is that there is indeed water on it. As noted in its history from the Earth side of things, there was a long-time belief that Mars always had water, but this was later revealed to be an illusion. However, as time went on, there were signs that there was some kind of water on Mars in its past, and possibly in its present. The only problem was that it couldn't be liquid water due to the thin atmosphere above the planet, as well as the total lack of magnetosphere. However, that doesn't mean they failed to find it. In July of 2018, scientists reported the discovery of a subglacial lake on Mars, the first known stable body of water on the planet. It sits 1.5 kilometers or 0.9 miles below the surface at the base of the southern polar ice cap and is about 20 kilometers or 12 miles wide. The lake was discovered using the Mars's radar on board the Mars Express orbiter, and the profiles were collected between May of 2012 and December of 2015. The lake is centered at 193 degrees east by 81 degrees south, a flat area that does not exhibit any peculiar topographic characteristics. It is mostly surrounded by higher ground, except on its eastern side where there is a depression. Add to that the various polar caps and other ice entities on the planet, and suddenly Mars isn't just a place to fantasize living on. We can do it because we know that there is water there that we can use. Number 6. Atmosphere. As noted, Mars has a very complicated history in regards to its atmosphere. Mars lost its magnetosphere 4 billion years ago, possibly because of numerous asteroid strikes, so the solar wind interacts directly with the Martian ionosphere, lowering the atmospheric density by stripping away atoms from the outer layer. Compared to Earth, the atmosphere of Mars is quite rarefied. The atmosphere of Mars consists of about 96% carbon dioxide, 1.93% argon, and 1.89% nitrogen, along with traces of oxygen and water. The atmosphere is quite dusty, containing particulates about 1.5 micrometer in diameter, which give the Martian sky a tawny color when seen from the surface. It may take on a pink hue due to iron oxide particles suspended in it. In short, this means that we can't just openly breathe the air on Mars, and going to the planet without a pressurized suit would be dangerous in all the ways that matter. As such, any colony that we try and build there will be one that has to be pressurized and have oxygen made and recycled so that we can breathe. Number 5. Soil. You might think it odd to wonder about the soil conditions on Mars, but in fact, they're some of the most important things that NASA scientists are trying to learn about. The Phoenix lander was sent to observe said soil, returned data showing Martian soil to be slightly alkaline and containing elements such as magnesium, sodium, potassium, and chlorine. These nutrients are found in soils on Earth, and they are necessary for growth of plants. Experiments performed by the lander show that the Martian soil has a basic pH of 7.7 and contains 0.6% of the salt perchlorate. This is a very high concentration and makes the Martian soil toxic, which is very bad considering we're wanting to try and use that soil to grow crops for the future colonies. The other problem with the soil that scientists have noticed is that it's incredibly clingy as well as sharp. This means that astronaut suits will have to be very strong to not get torn up by the dust, and advanced cleaning techniques, or creative ways to get in and out of the suits, will be needed to ensure that the dust doesn't find a way inside the colony itself, as this dust would not just damage the ships and colonies, but if breathed in could be very detrimental to the colonists themselves. As if that wasn't enough, there is speculation that there are billions of dollars worth of materials on Mars just waiting to be mined. Places like NASA and SpaceX are considering how to mine for those materials to help fund future missions to the Red Planet. Number 4. Pop culture. To say that Mars is part of pop culture on the planet Earth is an understatement in all the ways that matter. From basic references to being an integral part of shows and movies, Mars has been around. In the late 1800s, when people first observed the canal-like features on Mars' surface, many speculated that an intelligent alien species resided there. This led to numerous stories about Martians, some of whom invade Earth, like in the 1938 radio drama The War of the Worlds. According to an enduring urban legend, many listeners believed the story to be real news coverage of an invasion, causing widespread panic. Which is ironic because if they listened to the end of the program, the narrator clearly stated that it was just a story. Countless stories since have taken place on Mars or explored the possibilities of its Martian inhabitants. Movies like Total Recall, 1990 and 2012, take us to a terraformed Mars and a struggling colony running out of air. Martian colony and Earth have a prickly relationship in the Expanse television series and novels. And in the 2014 novel and its 2015 movie adaptation, The Martian, botanist Mark Watney is stranded alone on the planet and struggles to survive until a rescue mission can retrieve him. And keeping in line with the mythology of the planet, the name Mars has been awarded to various characters in cartoons and anime, and even video games for their strength, size, and godlike appearances. Number 3. Moons. The moons get their names from the horses that pulled the chariot of the Greek god of war, Ares. In ancient Greek, Phobos means light and Deimos means fear. Phobos, the innermost and larger moon, is heavily cratered with deep grooves on its surface. It is slowly moving towards Mars and will crash into the planet or break apart in about 50 million years. Deimos is about half as big as Phobos and orbits 2.5 times farther away from Mars. Oddly shaped Deimos is covered in loose dirt that often fills the craters on its surface, making it appear smoother than Phobos. The moons of Mars are another that are being studied very carefully, for while a full-blown colony may not be in the cards for these moons, a way station of sorts is possible, and certain theories about the future of space travel have pondered how these moons could help launch us into the back half of the solar system. Number 2. Terraforming. Given all the hardships that are on Mars, from the atmosphere to the soil to the seasons and more, it might seem that this is too big a risk to try and colonize it. And to an extent, you would be right. Even if everything goes right, it'll take years to set up a true colony on Mars. And to be honest, it probably wouldn't be the easiest living place for a long time. However, there are ideas and notions to try and warp Mars into a more sustainable habitat for us. Simply put, people are wondering whether we can terraform Mars into something more like Earth. Now obviously, this would be a grand endeavor, but it's not as much a sci-fi theory as you might expect. Some have put forth ideas of not terraforming the whole planet, but rather a section of the planet. Think of it like a country-sized safe zone where we could build the colonies in peace. Again, it's not that far-fetched. There are technologies out there that theoretically make this happen, including sending nanobots to the skies to help make an atmosphere of our own. Other theories could rework the ground itself into trying to make it something we can grow plants into. Right now it's all theory, but theory is the first step towards making something work. Number 1. Life on Mars. There are some in the world today who truly believe that Mars is where humanity will take its next grand step. If that is the case, it'll be the most significant thing humanity has done since landing on the moon. Plans from groups like NASA, SpaceX, and the ESA and more have their various plans to get to Mars and beyond. But will they happen? It's hard to say. And of course, even if they do land on the surface of Mars, will a colony really be that easy to set up? These are the questions we will have until we start taking steps towards human expansion in the universe. Number 9. The finding of Jupiter. A key part of astronomy as a whole is knowing when people first saw and documented key objects in the sky. This, of course, includes the planets like Jupiter. But as history has shown us, it's not something that was discovered recently, but rather farther into the past than you would expect. The first finding of Jupiter dates back to at least the Babylonian astronomers of the 7th or 8th century BC. The ancient Chinese also observed orbit of Suzing and established their cycle of 12 earthly branches based on its approximate number of years. The Chinese language still uses its name when referring to years of age. By the 4th century BC, these observations had developed into the Chinese zodiac, with each year associated with a Tai Sui star and God controlling the region of the heavens opposite Jupiter's position in the night sky. These beliefs survive in some Taoist religious practices and in the East Asian zodiac's 12 animals, now often popularly assumed to be related to the arrival of the animals before Buddha. The Chinese historian Shi Zhizong has claimed that Gan Di, an ancient Chinese astronomer, discovered one of Jupiter's moons in 362 BC with the unaided eye. If accurate, this would predate Galileo's discovery by nearly 2 millennia, though obviously this is a bit up for debate. Either way though, as you can see, Jupiter has been known about in the sky for quite some time, with many different civilizations keeping track of it and the entities around it. Number 8. The seasons and orbits. In regards to our solar system, Jupiter is the biggest of our planets. It's so big you can't put 1,300 Earths into it with no issues, which means that everything just has to be bigger on the planet. Am I right? Well, no. For example, in terms of its daily orbit, it rotates on its axis faster than any of the planets that we have in our system. For Jupiter, a day only takes about 10 hours. That's less than half an Earth day, and you thought time flew on our planet. But there's a catch, because that everything is bigger line does apply to how the year works on Jupiter. Given its distance from the Sun and how fast it moves, a year on Jupiter takes 12 Earth years, or 11.86 to be a bit more precise. That means for every 12 orbits around the Sun for Earth, Jupiter will have just completed a singular loop. So as you can see, it's a bit of a trade-off. You may have faster days on Jupiter, but you also have much longer years. Finally, for the seasons, the gas giants have a bit different of a system in terms to seasons, because they are made of gas, no solid surface, and that means that their clouds dictate their seasonal outbursts as much as the Sun does. To that end, Jupiter is known to be a very stormy planet, and then when it gets to a certain point near the Sun, it can change into one area and be cold, while the other can be hot. Oh, and seasons last 3 years there, so there's that. Consider this one of the many reasons we don't see to inhabit Jupiter for now. Number 7. The moons. In 1610, Italian polymath Galileo Galilei discovered the 4 largest moons of Jupiter, now known as the Galilean moons, using a telescope, thought to be the first telescopic observation of moons other than Earth's. One day after Galileo, Simon Marius independently discovered moons around Jupiter, though he did not publish his discovery in a book until 1614. It was Marius's names for the 4 major moons, however, that stuck: Io, Europa, Ganymede, and Callisto. These findings were also the first discovery of celestial motion not apparently centered on Earth. The discovery was a major point in favor of Copernicus's heliocentric theory of the motions of the planets. Of Jupiter's moons, 8 are regular satellites with prograde and nearly circular orbits that are not greatly inclined with respect to Jupiter's equatorial plane. The Galilean satellites are nearly spherical in shape due to their planetary mass, and so would be considered at least dwarf planets if they were in direct orbit around the Sun. The other 4 regular satellites are much smaller and closer to Jupiter. These serve as sources of the dust that makes up Jupiter's rings. The remainder of Jupiter's moons are irregular satellites whose prograde and retrograde orbits are much farther from Jupiter and have high inclinations and eccentricities. These moons were probably captured by Jupiter from solar orbits. 22 of the irregular satellites have not been officially named. One of the key moons that we must talk about, though, is Europa. For while it may be impossible to settle on Jupiter in the colony sense, the moon of Europa does have potential for being a potential landing spot for humanity jumping across the solar system. Number 6. The potential of Europa. The idea of colonizing a moon is not far-fetched. The problem has always been whether the moon makes sense for us to live on. For example, we can't really live on our moon despite it being so close because it doesn't have an atmosphere, doesn't have much water that we can use. The moon is said to be drier than any desert on Earth, and it doesn't have a natural energy source that we know of that can work in our favor to make things easier to live on it. We can explore it fine as we've shown, but barring advances in technology, it's not a feasible and logical place to live. While Europa is much farther away, it has things we can use to make colonization more plausible. For example, the atmosphere of the moon may be thin, which isn't ideal, but it does have a lot of oxygen, which means we could use that in our colonies to survive. We wouldn't be able to live on the surface without protection, but the air that we could breathe would theoretically be much easier to obtain than on other places. Then, as discovered rather recently, there is water vapor on Europa, with the water being both in the air as well as on the surface via ice and underground plumes. We could use that to help hydrate the colony and potentially even grow things on the surface in the right conditions. There are plenty of other problems that we'd have to deal with, I grant you that. But with water vapor being on the planet, we have a huge next step towards maybe having a colony on another planet, or a moon. Plus, it would be easier living on a moon of Jupiter than on Jupiter itself. After all, it's a very stormy planet with a big spot that you all know about. Number 5. The Great Red Spot. The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing an anticyclonic storm, the largest in the solar system, 22 degrees south of Jupiter's equator. It has been continuously observed since 1830. Earlier observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 360 years. Think about that for a minute. That would mean that a storm has been alive on this planet for hundreds of years, and we here on Earth are mad if stormy weather lasts a few days. The largest and most powerful hurricanes ever recorded on Earth spanned over 1,000 miles across, with winds gusting up to around 200 miles per hour. That's wide enough to stretch across nearly all U.S. states east of Texas. But even that kind of storm is dwarfed by the Great Red Spot. There, gigantic means twice as wide as Earth, with tumultuous winds peaking at about 400 miles per hour. Infrared data have long indicated that the Great Red Spot is colder, and thus higher in altitude than most of the other clouds on the planet. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Acoustic sound waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. As arguably one of the most popular parts of the planet, the Great Red Spot has been studied not just by people on Earth, but via probes and satellites that have passed by Jupiter or have gone to Jupiter just to study it, such as the 2 Voyager probes and the Juno spacecraft. They were able to give true images about the spot, as well as show much of how it worked in terms of rotation, size, and even composition. Though there are still many mysteries about the Great Red Spot, such as how exactly it has that color. Number 4. Rings? When you think about the solar system and the planets themselves, the one planet that you think about when it comes to rings is Saturn. But it was later discovered that while very thin compared to its neighbor, Jupiter does have rings as well. Jupiter has a faint planetary ring system composed of 3 main segments: an inner torus of particles known as the halo, a relatively bright main ring, and an outer gossamer ring. These rings appear to be made of dust rather than ice, as with Saturn's rings. The main ring is probably made of material ejected from the satellites Adrastea and Métis. Material that would normally fall back to the moon is pulled into Jupiter because of its strong gravitational influence. The orbit of the material veers towards Jupiter and new material is added by additional impacts. In a similar way, the moons Thebe and Amalthea probably produced the two distinct components of the gusty Gossamer ring. There is also evidence of a rocky ring strung along Amalthea's orbit which may consist of collisional debris from that moon. What made this a bit shocking was that despite people all knowing about Jupiter, they didn't figure out it had rings until 1979, when the Voyager probe passed by the planet and got pictures of the rings. Number 3. Pop culture. Jupiter also has a large presence in pop culture, including many movies, TV shows, video games, and comics. Jupiter was a notable destination in the Wachowski siblings' science fiction spectacle, Jupiter Ascending, while various Jovian moons provide settings for Cloud Atlas, Futurama, Power Rangers, and Halo, among many others. In Men in Black, when Agent J, played by Will Smith, mentions he thought one of his childhood teachers was from Venus, Agent K, played by Tommy Lee Jones, replies that she is actually from one of Jupiter's moons. And of course, for all of you anime fans, in Sailor Moon, one of the main characters was indeed Sailor Jupiter, a fan favorite character to many. Number 2. What makes up Jupiter? One of the things that defines Jupiter is that it's a true gas giant, the first in the solar system if you talk about the order of the planets, meaning from Mercury to Pluto. Given its many colors and the way it acts, you'd be fine for not knowing all that comprises the biggest planet in our solar system. Jupiter's upper atmosphere is about 88 to 92% hydrogen and 8 to 12% helium by percent volume of gas molecules. A helium atom has about 4 times as much mass as a hydrogen atom, so the composition changes when described as the proportion of mass contributed by different atoms. Thus, Jupiter's atmosphere is approximately 75% hydrogen and 24% helium by mass, with the remaining 1% of the mass consisting of other elements. The atmosphere contains trace amounts of methane, water vapor, ammonia, and silicon-based compounds. There are also traces of carbon, ethane, hydrogen sulfide, neon, oxygen, phosphine, and sulfur. The outermost layer of the atmosphere contains crystals of frozen ammonia. Through infrared and ultraviolet measurements, trace amounts of benzene and other hydrocarbons have also been found. The interior contains denser materials. By mass, it is roughly 71% hydrogen, 24% helium, and 5% other elements. No matter what way you look at it, though, the outcome is the same. It's a massive planet full of gas that we can't live on, in, or near. There's no surface to land on, and because it's a gas giant, we don't even know what its core is like, or even its size. Hence, as noted earlier, people are believing that the moons of Jupiter are a better place to land rather than the planet itself or even its atmosphere. Number 1. Continuing to explore. 9 spacecraft have visited Jupiter over the course of its life and the life of the space program. 7 flew by and 2 have orbited the gas giant. Juno, the most recent, arrived at Jupiter in 2016, but there are more on the way. The next planned mission to the Jovian system will be the Europa Clipper mission in 2023. Why continue to explore Jupiter? Simple. We still don't know everything about the planet. And if we are to habitate one of its moons, we need to learn even more about those moons and how they interact with Jupiter as a whole. So we will continue to explore so that one day we can boldly go where no man has gone before. Number 8. The finding of Saturn. Believe it or not, Saturn has a long and multi-layered history of being found, and its first appearances are further back in time than you would think. Saturn has been known about since prehistoric times and in early recorded history, as it was a major character in various mythologies. Babylonian astronomers systematically observed and recorded the movements of Saturn. It was also known about to both the Green and Roman cultures, who put them into their pantheons. In ancient Roman mythology, the planet Venan, Saturn, was sacred to their agricultural god, from which the planet takes its modern name. The Romans considered the god Saturnus the equivalent of the Greek god Cronus. The Greek scientist Ptolemy based his calculations of Saturn's orbit on observations he made while it was in opposition. In Hindu astrology, there are 9 astrological objects known as Navagras. Saturn is known as Shani and judges everyone based on the good and bad deeds performed in life. A scary thought indeed. Saturn's rings, which we'll talk about more later, require at least a 15mm diameter telescope to resolve, and thus were not known to exist until Christian Huygens saw them in 1659. Galileo, with his primitive telescope in 1610, incorrectly thought of Saturn's appearing not quite round as two moons on Saturn's sides. It was not until Huygens used greater telescopic magnification that this notion was refuted, and the rings were truly seen for the first time. Huygens also discovered Saturn's moon Titan. Giovanni Domenico Cassini later discovered 4 other moons: Iapetus, Rhea, Tethys, and Dion. Number 7. Orbits and seasons. As the 6th planet from the Sun, you would expect certain things from Saturn in terms of its orbits and its seasons, and some of them are true. But not unlike Earth, it has some severe differences in terms of its rotations. Just in regards to a year on Saturn, the ring planet takes 29 years to make it around the Sun. If you time it right, you'll basically live a third of your life before Saturn orbits the Sun once. Yet almost directly like its brother Jupiter, Saturn has a day that's only 10.6 hours long due to its fast rotation on its axis. Now, just as Jupiter has unique kinds of seasons, so does Saturn. But unlike Jupiter, Saturn has to worry about not just its connection to the Sun, but its rings to determine just how hot or cold it'll get. At certain points in its orbit rotation, the rings of Saturn will actually shade the planet, meaning that it'll get cooler. During this point, the intense winds on the planet will decrease by as much as 40%. This says nothing of the intense storms that can occur on the gas giant, and since seasons can last about 8 years on Saturn, that means the shifts can be slow at one point and then rapid in another. Number 6. Moons. The moons of Saturn are numerous and diverse, ranging from tiny moonlets, only tens of meters across, to enormous Titan, which is larger than the planet Mercury. 24 of Saturn's moons are regular satellites. They have prograde orbits, not greatly inclined to Saturn's equatorial plane. They include the 7 major satellites, 4 small moons that exist in a Trojan orbit with larger moons, 2 mutually co-orbital moons, and 2 moons that act as shepherds of Saturn's F ring. Number 5. Titan. Titan is a very interesting moon in both the literal and theoretical sense. Many actually believe that it is viable and even a logical place for humanity to touch down to make a colony. Some have even gone so far as to say that Titan should be the place where we go and make our first colony instead of the moon of our own Earth and Mars. Why would we consider going to a place like Titan to be a new home for humanity? There is some hard science that states why Titan might just be a viable place for us to live on, believe it or not. In terms of size, Titan is bigger than you might think. It is the largest moon that orbits Saturn, and it is bigger than our moon and even the planet Mercury. That being said, it's only 40% the size of Earth, so that would be a small problem. Yet we're not talking about inhabiting all the surface of Titan, just enough to get a colony or 2 going. However, what it lacks in space, it makes up for in gases and hydrocarbons, specifically liquid hydrocarbons, which has many scientists thinking that this is a great place to go because the amounts of liquid hydrocarbons that they're seeing on Titan is greater than that of the entirety of Earth. Titan is just covered in carbon-bearing material. It's a giant factory of organic chemicals, said Ralph Lorenz, who leads the study of Titan based on radar data from Cassini. This vast carbon inventory is an important window into the geology and climate history of Titan. Just to give you an image of what you can expect by that statement, there are literal seas and lakes filled with methane, ethane, and other liquid hydrocarbons. Some have been even measured to be bigger than the Great Lakes in the United States. Plus, Titan does have an atmosphere, and one comprised of very familiar elements: oxygen, hydrogen, nitrogen, and methane, all of which are in our own atmosphere here on Earth. Because of this, some scientists have stated that Titan is the most hospitable place in our solar system that humans could survive at. And that's only scratching the surface of what these gases can do for us. For example, while the water on the planet may not be able to be drinkable as it stands, it can be filtered to not only drink but produce more oxygen into the air. and the nitrogen, methane, and ammonia that is within the atmosphere and the planet can be used to make fertilizer, and thus allow us to grow food on the planet when the time comes. Now, yes, there are downsides, the biggest of which is that the moon doesn't have the strongest of gravity, and of course the distance between Earth and Saturn is rather significant, but if these two factors could be overcome, you might just find us shooting for Titan sooner rather than later. Number 4. Atmosphere. Focusing back on the main planet again, what is the atmosphere of Saturn like? The outer atmosphere of Saturn contains 96.3 molecular hydrogen and 3.25 helium by volume. The proportion of helium is significantly deficient compared to the abundance of this element in the Sun. The quantity of elements heavier than helium, metallicity, is not known precisely, but the proportions are assumed to match the primordial abundances from the formation of the solar system, in which Saturn is said to have been formed about 4.5 billion years ago. The total mass of these heavier elements is estimated to be 19 to 31 times the mass of Earth, with a significant fraction located in Saturn's core region. Saturn's atmosphere exhibits a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and are much wider near the equator. The nomenclature used to describe these bands is the same as on Jupiter. Saturn's finer cloud patterns were not observed until the flybys of the Voyager spacecraft during the 1980s. Since then, Earth-based telescopy has improved to the point where regular observations can be made, which of course we make full use of when we can. Saturn's usually bland atmosphere occasionally exhibits long-lived ovals and other features common on Jupiter. In 1990, the Hubble Space Telescope imaged an enormous white cloud near Saturn's equator that was not present during the Voyager encounters, and in 1994 another smaller storm was observed. The 1990 storm was an example of a great white spot, a unique but short-lived phenomenon that occurs once every Saturnian year, roughly every 30 Earth years, around the time of the Northern Hemisphere's summer solstice. Previous great white spots were observed in 1876, 1903, 1933, and 1960, with the 1933 storm being the most famous. If the periodicity is maintained, another storm will occur, possibly in 2020. The winds on Saturn are the second fastest among the solar system's planets after Neptune's. Voyager data indicate peak easterly winds of 500 meters per second, or 1,800 kilometers per hour. Number 3. The spacecraft around Saturn. As we are a curious race, Saturn has had many probes and spacecraft study it over the years since we've been able to launch things into space. Pioneer 11 made the first flyby of Saturn in September of 1979, when it passed within 20,000 kilometers of the planet's cloud tops. Images were taken of the planet and a few of its moons, although their resolution was too low to discern surface detail. The spacecraft also studied Saturn's rings, revealing the thin F ring, and the fact that dark gaps in the rings are bright when viewed at high phase angle towards the Sun, meaning that they contain fine light scattering material. In addition, Pioneer 11 measured the temperature of Titan, which, as we've noted, is a key part of Saturn's value. In November 1980, the Voyager 1 probe visited the Saturn system. It sent back the first high-resolution images of the planet, its rings, and satellites. Surface features of various moons were seen for the first time. Voyager 1 performed a close flyby of Titan, increasing knowledge of the atmosphere of the moon. It proved that Titan's atmosphere is impenetrable in visible wavelengths. Therefore, no surface details were seen. The flyby changed the spacecraft's trajectory out from the plane of the solar system. Almost a year later, in August of 1981, Voyager 2 continued the study of the Saturn system. More close-up images of Saturn's moons were acquired, as well as evidence of changes in the atmosphere and the rings. Unfortunately, during the flyby, the probe's turnable camera platform stuck for a couple of days, and some planned imaging was lost. Saturn's gravity was used to direct the spacecraft's trajectory towards Uranus. Finally, there was the Cassini-Huygens space probe that entered orbit around Saturn on July 1, 2004. It went to the moon Phoebe and sent back some images and data of the moon. It also discovered various things about Titan, tracked lightning on Saturn itself, and more. Number 2. Pop culture. Perhaps the most iconic of all the planets in our solar system, Saturn is heavily present in pop culture. No doubt because of how much people love the planet in one form or another. It provides a backdrop for numerous science fiction stories, movies and TV shows, comics and video games, including the Cthulhu mythos, WALL-E, 2001: A Space Odyssey, Star Trek, Dead Space 2, and Final Fantasy VII. In Tim Burton's film Beetlejuice, a dusty, fictional Saturn is populated by giant sandworms. And in the 2014 movie Interstellar, the wormhole that enables the astronauts to travel to another galaxy appears near Saturn. Saturn is also the namesake of Saturday, arguably the best day of the week. See? Your favorite planet helped inspire your favorite day. Cool, huh? Number 1. The rings. Without a doubt, when you think of Saturn, you think of the many wonderful and beautiful rings that surround the planet. They are easily the most noticeable of the 4 ringed planets in our solar system. Saturn's rings are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are made of billions of small chunks of ice and rock coated with another material, such as dust. The ring particles mostly range from tiny, dust-sized, icy grains to chunks as big as a house. A few particles are as large as mountains. The rings would look mostly white if you looked at them from the cloud tops of Saturn, and interestingly, each ring orbits at a different speed around the planet. Saturn's ring system extends up to 175,000 miles, or 282,000 kilometers from the planet, yet the vertical height is typically about 30 feet, or 10 meters, in the main rings. Named alphabetically in the order they were discovered, the rings are relatively close to each other, with the exception of a gap measuring 2,920 miles, or 4,700 kilometers wide, called the Cassini division, that separates rings A and B. The main rings are A, B, and C. Rings D, E, F, and G are fainter and more recently discovered. Starting at Saturn and moving outward, there is the D ring, C ring, B ring, Cassini division, A ring, F ring, G ring, and finally the E ring. Much farther out there is the very faint Phoebe ring in the orbit of Saturn's moon Phoebe. We are fascinated by the rings of Saturn, especially when it was later discovered that Jupiter, Uranus, and Neptune also had rings of various sizes and natures. We've also found planets and galaxies far, far away that have ring systems that are massive even when compared to Saturn. One planet is even named Super Saturn because of how big its rings are. Number 9. Its discovery. Before diving into the various facts about Uranus and how it quite possibly became what it is today, we need to first understand how it got discovered, because it's a tale that is rather familiar when it comes to the outer planets. You see, Uranus has been observed on many occasions before its recognition as a planet, but it was generally mistaken for a star. Many other planets and dwarf planets had similar misidentifications because of their distance from the Sun and the Earth and their slow orbits. More on that later. Possibly the earliest known observation was by Hipparchus, who in 128 BC might have recorded it as a star for his star catalog that was later incorporated into Ptolemy's Almagest. The earliest definite sighting was in 1690 when John Flamsteed observed it at least 6 times, cataloging it as 34 Tauri. The French astronomer Pierre-Charles Lemonnier observed Uranus at least 12 times between 1750 and 1769, including on 4 consecutive nights. Oh, but it didn't stop there though, far from it. Sir William Herschel observed Uranus on March 13, 1781, from the garden of his house in Bath, Somerset, England, which is now the Herschel Museum of Astronomy, and initially reported it in April 1781 as a comet. With a telescope, Herschel engaged in a series of observations on the parallax of the fixed stars. This is infinitely ironic because of the fame of Herschel and his discoveries of other major celestial objects in the sky. But most of all, he kept asserting it was a comet to everyone that mattered, although one time he did liken it to a planet. The power I had on when I first saw the comet was 227. From experience, I know that the diameters of the fixed stars are not proportionately magnified with their higher powers as planets are. Therefore, I now put the powers at 460 and 932, and found that the diameter of the comet increased in proportion to the power it ought to be, on the supposition of it not being a fixed star, while the diameters of the stars to which I compared it were not increased in the same ratio. Moreover, the comet, being magnified much beyond what its light would admit of, appeared hazy and ill-defined with these great powers, while the stars preserved that luster and distinctness which from many thousand observations I knew they would retain. The sequel has shown that my surmises were well founded, this proving to be the comet we have lately observed. Oops, things only got worse later on. Herschel notified the astronomer Royal Neville Maskelyne of his discovery and received this flummoxed reply from him. "I don't know what to call it. It is as likely to be a regular planet moving in an orbit nearly circular to the Sun as a comet moving in a very eccentric ellipsis. I have not yet seen any comma or tail to it." Herschel, though, refused to believe it was anything other than a comet, but other astronomers out there were starting to get wise to the fact that this could be something else, like, a planet. Finnish-Swedish astronomer Anders Johan Lexell, working in Russia, was the first to compute the orbit of the new object. Its nearly circular orbit led him to a conclusion that it was a planet rather than a comet. Berlin astronomer Johann Elert Bode described Herschel's discovery as a moving star that can be deemed a hitherto unknown planet-like object circulating beyond the orbit of Saturn. Bode concluded that its near-circular orbit was more like a planet's than a comet's. The object was soon universally accepted as a new planet, and even Herschel had to admit it after a while and note to Joseph Banks that he was wrong and that other astronomers had done right by labeling it a planet. Astronomy wasn't what it is right now back then. Their technologies mixed with their understanding of the universe was limited. For them to find Uranus and track its movements in 1781 is astounding, so it's understandable that they could get the classification wrong. Number 8. Its name. When you think about the seventh planet from the Sun, your eyes and mind no doubt go to its name, Uranus, which, as we'll explain later, has become the butt of many jokes. But back when the planet was truly found, that wasn't the intention at all. The name of Uranus references the ancient Greek deity of the sky, Uranus, the father of Cronus, Saturn, and grandfather of Zeus, Jupiter. Consensus on the name was not reached until almost 70 years after the planet's discovery, which is a very long time when you consider how long the other planets took to get their name. During the original discussions following discovery, Maskelyne asked Herschel to do the astronomical world the favor to give a name to your planet, which is entirely your own, and which we are so much obliged to you for the discovery of. In response to Maskelyne's request, Herschel decided to name the object Georgium Sidus, George's star, or the Georgian planet, in honor of his new patron king, George III. He explained this decision in a letter to Joseph Banks. In the fabulous ages of ancient times, the appellations of Mercury, Venus, Mars, Jupiter, and Saturn were given to the planets, as being the names of their principal heroes and divinities. In the present more philosophical era, it would hardly be allowable to have recourse to the same method and call it Juno, Pallas, Apollo, or Minerva for a name to our new heavenly body. The first consideration of any particular event or remarkable incident seems to be its chronology, if in any future age it should be asked when this last found planet was discovered. It would be a very satisfactory answer to say, in the reign of King George III. While that may have seemed logical to him, the rest of the world didn't agree, mainly because it was a British king getting the name and the rest of the world didn't think that was right. Thus, other names were suggested by people from all over. Ironically, someone thought it should be named Herschel, because it was he who discovered it. Just as ironic, someone felt it would be good to name it Neptune, and had a lot of support around that name. In a March 1782 treatise, Bode proposed Uranus, the Latinized version of the Greek god of the sky, Uranus. Bode argued that the same should follow the mythology so as not to stand out as different from the other planets, and that Uranus was an appropriate name as the father of the first generation of the Titans. He also noted that elegance of the name in that just as Saturn was the father of Jupiter, the new planet should be named after the father of Saturn. Many agreed, and thus Uranus was the most widely accepted name. However, because of a holdout, the HM Nautical Almanac Office, the name was not truly universally accepted until 1850. So as you can see, finding a planet is hard. Naming a planet in those days, that was even harder in some ways. Number 7. Orbits and rotations and seasons. Focusing now on the planet itself, Uranus is a dichotomy of curiosity when it comes to its orbits and rotations. Why is that? Because if you look at its daily rotation, it's only 17 hours long, which means a day there isn't even as long as a day on Earth. However, when you get into its orbit around the Sun, it takes 84 years to go one full rotation. Think about that. That means that one full orbit for Uranus can be equivalent to an entire human life, if not longer when you look at the average of it all. This, combined with its unique tilt, also makes the planet very unique in terms of its seasons. The planet's North Pole experiences 21 years of nighttime in winter, 21 years of daytime in summer, and 42 years of day and night in the spring and fall. Number 6. Funny tilt. As the series Schoolhouse Rock adequately noted in their song Inner Planet Janet, Uranus is built on a funny tilt, which is 100% accurate because unlike every single planet in our solar system, Uranus is sideways in the literal fashion. This was proven by many metrics, but the biggest one being its rings. They're perfectly vertical, unlike Saturn or other planets we know of that have horizontal rings most times. Furthermore, this was proven when studying its axes, which are tilted 98 degrees, relative to the plane of the solar system, meaning it essentially spins on its side. No other planet in the solar system is tilted as much. Jupiter is tilted by about 3 degrees, for example, and Earth by about 23 degrees. But what caused this? No one is really sure. However, certain scientists and astronomers from Japan suggest that a cosmic impact may be to blame. Not only that, they think that this cosmic impact could have not just put Uranus on a funny tilt, but also helped make its many moons. Given that none of the other planets in our solar system have this kind of a tilt, it's fair to say that they might be right in their notion of an impact causing Uranus to be like this. Number 5. Atmosphere. Uranus's atmosphere is mostly hydrogen and helium, with a small amount of methane and traces of water and ammonia. This methane gives Uranus its signature blue color. While the probe Voyager 2 saw only a few discrete clouds, a great dark spot, and a small dark spot during its flyby in 1986, more recent observations reveal that Uranus exhibits dynamic clouds as it approaches equinox, including rapidly changing bright features. Uranus's planetary atmosphere, with a minimum temperature of 49 Kelvin, minus 224.2 degrees Celsius, makes it even colder than Neptune in some places. Wind speeds can reach up to 560 miles per hour or 900 kilometers per hour on Uranus. Winds are retrograde at the equator, blowing in the reverse direction of the planet's rotation. But closer to the poles, winds shift to a prograde direction, flowing with Uranus's rotation. Number 4. Pop culture. Uranus is the butt of more than a few jokes and witty and not so witty puns, but it's also a frequent destination in various fictional stories, such as the video game Mass Effect and TV shows like Doctor Who. The radioactive element uranium was named after Uranus when it was discovered in 1789, just 8 years after the planet was discovered. In anime, Uranus has a very special place in history via the show Sailor Moon. Uranus was one of 2 sailors who came later in the series, and the character of Uranus was gay alongside Neptune. But in the American version of the show, they were cousins. What's more, as if to showcase the uniqueness of Uranus and show that she, like the planet, was sideways in certain measures, she dressed like a guy when not in fighter form by wearing suits. In the sports world, on the show Pardon the Interruption, host Tony Kornheiser wastes no chance to make a Uranus joke. Why? because he can and he loves to do it. And he's not the only one, as we've noted. Even Mass Effect had a bit where they had a Uranus joke when you probe the planet for materials in Mass Effect 2. Because of its name, regardless of the origins and meaning of it, Uranus will always be made fun of by those who want a quick joke. Number 3. Magnetosphere. Uranus has an unusual, irregularly shaped magnetosphere. Magnetic fields are typically in alignment with a planet's rotation, but Uranus's magnetic field is tipped over. The magnetic axis is tilted nearly 60 degrees from the planet's axis of rotation, and is also offset from the center of the planet by 1/3 of the planet's radius. Auroras on Uranus are not in line with the poles like they are on Earth, Jupiter, and Saturn due to the lopsided magnetic field. The magnetosphere tail behind Uranus opposite the Sun extends into space for millions of miles. Its magnetic field lines are twisted by Uranus's sideways rotation into a long corkscrew shape. Number 2. Rings. Uranus has 2 sets of rings. The inner system of 9 rings consists mostly of narrow, dark, gray rings. There are 2 outer rings. The innermost one is reddish like dusty rings elsewhere in the solar system, and the outer ring is blue like Saturn's E ring. In order of increasing distance from the planet, the rings are called Zeta, 6, 5, 4, Alpha, Beta, Eta, Gamma, Delta, Lambda, Epsilon, Nu, and Mu. Some of the larger rings are surrounded by belts of fine dust. Number 1. Moons. Uranus is one of many planets in our solar system that have many moons. At present count, it has 27. Their composition is stated to be half water ice and half rock, which could have some potential for things in the future if we're able to study them and get closer than we can right now. Another thing that separates the moons of Uranus from others is that their names are different. If you look at the grand scale of the solar system we're in, you'll see that the planets and moons that are named are gods, deities, and other beings of mythology. But not Uranus. Its moons are named after Shakespearean characters and ones written by Alexander Pope, showing that even when it comes to names, Uranus is not like the other planets.